Then we moved on to this idea called RLHF. Reinforcement learning human feedback, which is probably one of the biggest ways by which the models are able to get inputs, right? The models input, output, can we actually take something from here and give it back here? Simple control systems feedback, RLHF is the idea, but looks like this is one way by which we can actually improve the performance of the model setup built. Right, so here collect and demonstrate data. Human beings are making some annotations. And then these annotations are being compared. So giving a result something like this, which is different annotations, how relatively they are actually to each other, helps making use of these annotations very well. And then once you have it, can you actually use that in producing the results? Right, so we can, I think we spent quite a bit of time again in RLHF, the constructs of the RLHF, some studies that are done on using what are the problems of RLHF, what are the advantages of RLHF, all that. We saw some idea called alignment problem. I think this is also a very, very critical topic as part of this class, which is to say that whatever that we are building as human beings for this technology, it should be doing what it is supposed to be doing. Right, technically difficult to distinguish between AI. So this is the one that I said earlier. Also, take a look at some of the recent work that is going on in this area of differentiating, given an article written by a human being and AI generated text, how do you find the difference? Right, this is the part of the long report that I referenced to walk through different RLHF ideas. Then we moved on to this idea of unlearning. Right? Unlearning also has picked up pretty heavily in the last couple of months. Many methods have been created, many research output has come, and then it is being also talked heavily in the industry to see how these models can do unlearning. And the reasons for unlearning are private data, stale knowledge, copyrighted materials. All of this are reasons for why we need unlearning. There are many ways by which unlearning is done: exact unlearning, inexact unlearning, all of that we saw in detail. This is one method by which exact unlearning is done. The main idea here is sharding, where you break the model into different models, and whatever you want to unlearn is in one part of this, so it's easy to actually unlearn. You don't have to go relearn all the entire model. Instead, we need to do only this part. Right? That's the idea here. Yeah, exact unlearning. We spent again. I think we spent large amount of content for a week on just unlearning. Studying different unlearning methods, exact unlearning, approximate unlearning, how does an approximate unlearning work, unlearning via differential privacy. Differential privacy is one of the primary motivations for unlearning also, because your personal information is in the model, you want it to be removed. One of the metrics that was generated is called interclass confusion. Again, this idea of interclass confusion is catching up, which is a metric to measure how well a model is doing unlearning. Yeah, and another idea of this corrective machine learning is also building on. There is some more work from the time we saw this content until now. Very few benchmarks have been created to study the idea of unlearning. TOFU is one benchmark where they had actually created fictitious authors, and you can actually go study how the unlearning happens in this data set, in this benchmark that they had created. I had requested you to go look at the online implementation here. If you have not already done, please do so. And then there is also WMDP, which is also a benchmark for this. This one is more on the biosecurity and topics around that. It's weapons of mass destruction proxy, and it has about 3,700 multiple choice questions about the topics of biosecurity, cybersecurity, and chemical security. Then we studied what representation engineering is. Representation engineering, I mean, if you go look at this paper, it's got a lot of attention also. Representation engineering, and then we did a whole lot of hands-on session in representation engineering also. Then we moved on to the idea of graph unlearning, right? So this one is, until now we talked about labels or knowledge unlearning. This one is graph unlearning. And this image shows you what is the motivation for doing graph unlearning. Graphs are all over the place, social networks, transportation, interactions everywhere. So you want to actually forget something from the graph. How do you do that? Right? So you want to forget the edge, you want to forget the feature, you want to forget the node itself. Different ways of unlearning methods have been created, and we spent some time on this. Here also, probably last 12 weeks, the topic has actually moved very fast. There are many research results, at least in the area of graph unlearning. So here is a comparison of our different graph unlearning methods. If you see all of them, I mean, if you do the table again now, there may be more also here. This is 2023, but there are some metrics that have come up in 2024 also. So this is basically to show you that what are the different unlearning methods, what do they do, what kind of are they unlearning feature, are they unlearning edges, are they unlearning nodes. That's what this table provides. Then I think about 2 weeks or so we spent only on bias. Bias is probably the longest content that we covered as part of this course. Looking at bias from very different perspectives. First, what is bias? Why is it even a problem? Different domains look biased differently. What is our definition of bias, which is systematic favoritism or discrimination towards certain groups and outcomes. So one of the thing that I have also understood over a period of time is that, is it a problem if there is bias and there is no implications because of that, right? Or is it a problem that there is bias and there is implications also? No implications and implications. Is this a problem or is this a problem? Both has bias here, let's say. Yeah, I think again, one has to have a lot more understanding of what's going on, particularly I think what does the society need, or what is that the product manager is deciding, what is that the company has the policy for. I think those are the ones that are going to make the final decision on what it will take to decide on these topics like bias, right? Social alignment, stereotypes. There are also called value alignment, right? There are many of these topics that are coming up or is there where the question of alignment, bias is also a question of alignment. Meaning I think most of the topics that we saw as part of this course is actually as part of the alignment also you can describe. Different categories. I think initially we spent quite a bit of time in bias, looking at various definitions of biases, lots of literature, and what kind of bias they had actually studied. In this case, gender, profession, race, religion, sexuality, autocomplete, dialogue rewriting, right? So where the bias, what type of bias did they actually study? Continuing on the different types of biases, categories of biases. Many biases are also geographical. Demographics can affect the perception. In India, that black man got into a flight. USA, that black man got into a flight, may be very different, right? The perception of this statement is very different in these two geographies. Then we saw again quite a bit of literature around this topic, starting from look in legal domain. There is bias in terms of the bail predictions that has happened, in terms of decisions that were done in court cases, all of that. The bias can happen in different ways in the entire life cycle of a machine learning model, right? So that's what this graph shows you. Collecting data, labeling data, training data, models, uses see an effect. Right? The bias can come in all components of the entire life cycle. It's not only the text, it's not only the text that is generated which has bias. You can also see these it's not only the language models that has the problem, we can also see the problems in the vision models, right? So here is an example. This example again shows you some indication of what the vision models biases are, but there are lots of examples now. I'm pretty sure now, given that you've taken this class, given that you may have looked at these topics over the last semesters, even outside the class, I'm pretty sure you'll be able to come up with different examples where these biases are in vision model. How to combat these biases? Now, until now, we were only measuring bias. So now we are saying that, look, can I actually do something to debias this in the models? Many different data sets have been created. This one is one of the data sets called stereo set, which helps in studying the bias. Right, more this cross pairs, which is again a different type of a data set, which is to give you different sentences, examples of biases, and use that to study the bias problem. Auto debias, again, another paper, many other popular works that have come up in terms of this bias. One another problem with the bias is that it's not just the sort of the examples that we saw until now, right? It's also the context. Women can't drive, and then I'm unable to attend because of guardrail, but the context was something else. Right? So adding this context, how does it help is the question some people are asking. Yeah, context guardrails, which is particularly, again, there are some solutions that are built to increase the context in the prompts. If you increase the context, how well do they perform? Some work in this space. How specifically, how does the model work is what is shown in this slide, and we spent some time in understanding it also. Then we moved on to look at vision models, right? Vision models, biases, particularly this one, again, looking at how some context given, which in the form of action-based will help, right? Profession like this images versus like this images can actually help the models better. In this case, you can actually see what the doctor is doing. There's a teacher teaching the class compared to how could you have predicted that this is actually a teacher. That's what this action-based representation of profession helps. There was this interesting study done for all the professions that they wanted to look at. They actually created the action, but instead of a human being, they kept a robo for the same thing, and saw whether there was any difference in the bias, right? Because if you go back to this example, the bias generally we talked about are because of the human being that is there, right? The example where we showed person cooking and a right, so right, cooking and having this conversation. Right. So if you change this to be a robo, will the bias still be there? Is the question that they were asking. Interesting question, interesting results that they found, which we also spent some time during the course. Right. Yeah. So this is again same theme where if you text to image generation, if you change the person to be a robot, what does it do? And they tested against different models to show how well it performs. Many more challenges again in terms of the bias topic, measuring bias, debiasing, cultural relevance. How can you make all these results very culturally relevant is a large question. Then about 2 weeks, we went on to this topic of privacy. Hugely differential privacy was covered in 1 week. And the next week, we saw fairness in machine learning, looking at different methods, how fairness can be embedded in the ML models. Then we came to a topic called transparency. Again, transparency around the idea of provide clarity about models' inner workings. Interpretability also will, when we saw, we kind of gave a very similar definition of what the model is actually doing. So transparency could make it easier for monitors to detect deception and other hazards. If you know what the model is doing, why it is doing, it's easy to actually find out, right? We spent a lot of time in, again, understanding different methods, pixel attribution methods, salient maps, right, GAN2, style GAN3. How does these methods work? What are the reasons why some of these methods fail? Examples of how these models perform, salient maps, different types of salient methods, and looking at the output of these images can also be deceptive. Talking about some of these. How do you also do some testing when we set up these studies to make sure that some sanity checks are done? Some methods by which the models identify the objects. In this case, it's actually doing masking. And then we saw some examples of comparing these different methods. We spent some time on understanding LIME as a topic, which is very helpful in understanding how the models do what they do and why they do also, right? So this is local interpretable model agnostic explanations, which is the idea is that can I actually get very local about identifying the data point that we have, and this is the way it was operationalized. So this is the model, this is the data point that we have to decide. All these are some local images. The distance between the images is one metric, and how do you use that as part of the model itself? That was the paper. We also saw something of SHAP based on the Shapley values. We saw something called as GradCam, again a method by which transparency can be improved. Some advantages and disadvantages of gradient based, which is the methods that we saw until now. I put some links to hands-on. I hope that you were able to go spend some time on these code base to help you understand how these models work. And all of them have had some implementations of these models. Saliency maps need not be only for the images, it can be actually for the text also. Example is here. Then we saw the idea called feature visualization, which is to get at the neuron level, online implementation of some feature visualization techniques. I also requested you to go to take a look at this OpenAI implementation. Then we saw this idea, because these are all part of the transparency topic. So we want to know which part of the image is actually making effect on deciding that this is a sparrow, this is a cartoon, this is a dog or an elephant or something. This idea is called proto-PNet, which takes an image, dissects it into small pieces, uses that to say take up similar images, and then shows a heat map of which parts of the image it used to make the decision. Building on the idea for transparency itself, interpretability methods also we saw. How do you get understanding of what the layers are doing? Is there a way to get some heat map of how the models are, which aspect of it is the model using? For example, in this case, if you see, is it using the bottom part to decide the car? It's using the top part to decide that it's a car, right? This is one of the ideas also that we saw earlier called mechanistic interpretability. Probing as part of, again, interpretability loosely refers to the class of methodologies in interpretability to check whether the representations encode information reliably for some specific task. Downstream task can be something, and can you actually make sure that the representations actually encode the information that is required. Then we saw Trojans. Trojans, small change here will make the car not to stop, but to actually move. Similarly, you could actually think of Trojans being everywhere. How do the Trojans get into systems? It could be that publicly available data sets, models, sharing libraries can have these Trojans. If you look at this, data poisoning is happening because of some trigger. That trigger is influencing the change from 7 to 8. Why does that happen? Can we actually go re-identify what the trigger is? How do you get to the trigger from the output? All of that is what we saw. Right? Deducting techniques, right? Which is a Trojan, and can you actually find ways to go back to the trigger? This is the original trigger, reverse engineered trigger. How close is it and how well it can perform? Then we saw a method for meta networks, which is create another neural network to analyze Trojans. Once you have identified Trojans, can we actually create methods to remove the Trojans? Then we had this last 2 to 3 weeks on giving you an insight of the one aspect of it is the last post condition, which is giving you an insight of research, but also what do people around the world say, right? This was fantastic conversations that we have had with people around the world talking about this topic and getting their inputs. I really hope that this was very useful for you, because this was very useful for me, meaning at least this is Professor Ramaya Krishnan from a public policy point of view. This is Professor David Kruger from a technical point of view, and this was a panel discussion around industry talking about what are the different things that they are doing. These two are academic people talking about how AI policies, regulation, AGI, all of that is going on. Meaning I learned a lot by these interactions. You would have seen me asking them questions, but I hope that you were able to also relate to some of these questions that were asked to them and answered. If you have any other questions that you would like an answer for, please send it in the mailing list. I can find some ways to find answers also, either from them or from others. That's about the panel. Last week and a half, I think we did more of paper reading in these topics, consistency, interpretability, graph explanations, all of that. These are research that are going on right now. So these are all very hot topics in some sense. It'll be pretty nice if you think about these topics, and if you want to even be part of some of the work that is done, please feel free to reach out. One of the cool things about this course that I felt while creating it, and I also think that it's still the cool aspect, is this whole hands-on content that we generated for this course. I've been telling people about go look at the course content to get a view of the hands-on, but we did for robustness, transformers, Hugging Face, representation engineering, machine learning, PyTorch, neural networks, bias, interpretability, and jailbreak. It definitely very, very responsible AI safety topics. Okay, I feel that's what one of the cool things for this course is. Thank you for taking the class. I hope it was helpful to you. I enjoyed actually creating the content. As you would have seen, we were creating the content as we were doing the course also. So I really, really hope that you enjoyed the class. We enjoyed teaching it to you. Look forward for future interactions. If I can be of any help in anything that you would like to do in this topic or otherwise, feel free to reach out to me. Good luck.